Looking good. Okay. Hello, my name is Jonathan Lira. I hope everything's going good. This is my first attempt for my final video for CSI 1370 with Dr. Kim. Today we'll be reviewing the first things, the basics of C++ programming language. I'm gonna be providing some slides, and also I will be going over some examples on Visual Studio Code, which is the application we use throughout our class to learn everything about programming, the basics of programming. First thing, data types. On this program, we'll be using several data types that are designed specifically for different purposes. Depending on which one you use are the type of things you can store or the information you can use. The pretty basic ones are integers with the keyword is int, the boolean, which are the keyword is bool, double precision, which mean that you can use a decimal point on your variables. An example of these would be this. Since I use this basic program, I said integer a. Integer is the data type and a is my variable. Since I use an integer, I can store an integer value into the variable. If I were to use a double here, I could store 100.75, and if I add here a cout, which is something we'll be reviewing later on, you guys can see this. Let me just save it, compile, and run it. But as you can see, the output came out as 175. But if I were to bring this back to an integer and then save it and try to run that, we compile it, we run it, you can see that it didn't took the 0.75 because in an integer variable you cannot store something with a point. This should be a double, as you can see right here. Variables. Variables are locations that you create in order to store data and use it to display it later on. As I already told you in the last example, this is my variable. This is just a name. This is just a place where I can store data like this, depending on which type of data I decide to use. Double. Let's bring it back to double. Now we can have this. We can set multiple variables on a single line, and this will all be ready to use for us to store more values. We just have to declare them. As you can see, if I add here n9 and I cout my b2, have to save, compile, and run. Since I already declared the variable here and I set a value over here, boom, there we go. We can have two variables now available for use. Next thing are identifiers. Identifiers are names used to identify a variable, function, class, or any user-defined item. For the identifiers, it's just the name that you want to put to your variable. As in the last example, I used A, B, and C, but there's almost anything except for the C++ keywords which are everything that is a function, everything that has already a value, or like you cannot use hashtag include because this means something in the program. You cannot use iostream as a name variable, as an identifier, because all of those things are already in the program and they mean specific things that are not free to use. The identifiers must start with a letter or an underscore. I already did this. Variable declaration means that while you have line 4, you're just creating that space, but there's nothing in it. Like A is nothing, it's just a 0, it's just a space for you to use. What you want to do is use line 5, which is A equals equal sign, which means assigning. This is an assignment operator I will be talking about later on. But an assignment operator means that this on the right side of the assignment operator is going into this, which is the left side of the assignment operator. A will store 100. As I showed you in the last program, A equals 175, which you can see here. When we see out the 175, we tell the program to tell us what A is on this line. We're telling the program, hey, show me A. You can see that once we did this, it is 175. But if we were to delete this line and not put anything on it, look what happens. There's nothing there. It's an error. It's just a random number, which is not true. Assignment operators. I was talking about this right now. Is that equal sign, and I got ahead. I just told you this, guys. On the left side is the variable, and on the right side is the value you want to store into this variable. There's several assignment operators. There's plus, minus, division, multiplication, and modulus. These are useful when you want to make a variable equal to something plus something else. Let me show you this in a program that will be easier. Instead of having just A equals 100, we can change this to integer, and we can get rid of this. Instead of just having A equals 100, we can use A plus equals 100, and we can say that A is equal to 15 here. So what we're doing is we're creating the variable, we're setting a value, we're assigning it a value, and then the plus equals means that A is gonna be equal to whatever A was plus 100. So the output of this program should be 115. Let's see if it runs properly. 115. So plus equals allows you to add something without having to do an actual addition or rewriting those variables. The same thing with minus equal. It's exactly the same thing, but instead of adding 100, it's gonna subtract 100. Negative 85. Here you go. Stream and libraries. At the top part of any program, you want to have include iostream, which is a library of keywords and functions that will let you use shortcuts and apply those functions in your program. Without this, we could not use any of the variable types, any of these things. We could not use integer, we could use not main. The program wouldn't recognize this, because if I erase this, as you can see, the cout and the end line, they're not colored, so the program doesn't recognize those things. When you include the IO stream, basically what you're doing is letting the program know what you're gonna use and what type of programming you're gonna do. Libraries are a group of more functions that have more specific uses. There's a lot of different libraries that will let you open up and expand the functions that you have available for using your programs. For example, CMath is one of those libraries, and it includes things like the square root or the powers without you having to put an actual division and put 8 divided by 8. You can just put sqrt and it will give you the square root. There's also another library that's called ctime. Ctime is a library that the main thing that is used for is to randomize things. There's a function called rand, and the rand function, what it does is that it can give you a random value when you set some limits to it. So you can put random of 100, and it'll give you a random value from 0 to 100, and that's useful when you want to randomize things or make games that involve luck or something like that. The sin and the cout. Sin and cout are two keywords that give you the ability to display something out in the program. This is cout, or store user input into a variable, as you can see in this program. I'm gonna make a quick program, which is a program that will ask for your age. That's it, and then display it. We have to set an integer, which we could say it's age, right? And we want to display something on your program, so you use cout. You have to put the two little brackets. When you put something in the quotation mark, it will show it exactly as it is. It's like if you're putting in text. So we can ask the user, how old are you? You can put an end line. What the end line does is that it skips a line, so you can have a clear line for whatever you're doing next. Then we're gonna sin. Sin allows the user to input something into a program, so it's gonna ask you for a response. And the sin, you put the little brackets, and you wanna add a location. So what this line does, line 4, is it's gonna display something. This is what you want to display. How old are you? You're gonna skip a line, and then you're gonna receive whatever the user, in this case us, is gonna input into the program. So what you want to do next, now you have that information stored into your integer, and we could put something like you are age years old. So what this is doing is gonna display the question. It's gonna ask you, the sin asks you, lets you input something as a response, and you're gonna store it in your integer that you declare, that you started initialize before, and then you're gonna see out you are age years old. In the age, you're gonna have whatever the user inputs, so it should be true. Let's compile this program, g++ cout.cpp. We execute it. It's taking a long time. So here you go. How old are you? So we're in this part of the program. Now, as you can see, it's waiting for me to input a response. So I'm gonna say 18, and then it's gonna see out you are the age, which is my input, years old. And as you can see, that's how sin and cout work. There you go. I had put it in as an example. Arithmetic operators. As you may know them, and they're all available, and they're super useful to do any type of operations. Let's put them to try in a simple program. Let's set an integer, a in this case, and they're useful for the declaration. Integer, a is equal to 5 plus 8. If you want to be more organized about it, you could put everything into parentheses so you can separate each of them. Let's try this program. It's super easy to use because it's just adding and subtracting, and it will give you the value. Oh, sorry. I forgot to cout. Cout a. So this line, you're initializing your variable, you're creating it, and on this line, you're assigning a value to it, in this case, using an arithmetic operator of plus. So your integer a, your variable, should be equal to 5 plus 8. So now I did it right this time. As you can see, the output of the program is 13 because we're asking it to display a. It will be the same thing if we do a multiplication. We just have to save it, compile, and run it. Your variable a is equal to 5 times 8. Here you go. The output is 40. The increment and decrement, those two are not regular ones. The increment, what it does is that you can periodically increment the value of the variable. So let's say we're initializing the variable and declaring it to 5. So the value of a right now it's 5. If we add a line that says a plus plus, by default the plus plus means that it's adding 1. So whatever a is, it's gonna add 1 to it, and that's gonna be the new value of a. So the output of this program should be 6. As you can see here, 6. These operators also work if you add a value. So we could put plus plus 5. No, we can't. Excuse the last example, I got confused with another function. So the decrement will be the same thing. A minus minus. The output of this program should be 4. 4, as you can see. Let's go continue. Now we have relational operators. These relational operators require two variables. What they do is that they compare two variables to each other. So here we can say b is equal to 4. What I can do to try it, let's say we want to try the greater than. We can use an if statement. I know I haven't explained it, but later on we'll do so. If a is less than b, see out. These relational operators are good when you're trying to set a condition for a value. This is missing a semicolon. Let's just put an example like this. Yes. So what we're saying is that if a is less than b, which is not true in this case, because a is 5, which is greater than b, which is 4, you want to display a yes. And if it's not true, if this condition is not met, it's a no. So what we're trying to test here is that a is not less than b. So let's try it out. Let's go for compile and run it. So we have our variables, it's analyzing them, and it's a no. But if we were to change the sign to a greater than, we could compile this, run this, and it will output a yes, because it's comparing this to this. This is what the relational operators are good for. We could use an equal to. Equal to is not the same thing as assigning. Assigning means this is going into this, and this is if this equal to is comparing A to B. So if A is the same thing as B, it will be true, and it will run a yes. So let's compile, run. It's a no. But if we were to change the value of b to a 5, which will make this true, which what we're seeing here is that it's comparing these two, we can compile and run it, and it will say yes, because now they're equal to. It's comparing A and B. It's saying here it's a 5, here it's a 5, so it will give us our output. Logical operators. If you have any knowledge on electric circuits, you will know these gates. These are known as logical gates in the electrical area, and or not. The easiest example I can think about is, I have one prepared here. I think here you go. I already prepared one. I have two integers. I'm asking the user to input those two integers. So then it's going to compare them. If my first integer is greater than 5 and my second integer b is greater than 5, it will see out true. Let's try it on. So here we're going to login.cpp. We're going to what? Excuse me. We run it. Here at this point, we're in this line 5, it's asking us for two values. I'm gonna put 5, no, I'm gonna put 6 and 8. Since they're both of them are greater than 5, the output should be true. If I run it again and I put a 4 and an 8, there's no output because they're not true, because it's an AND. But now let's say I change this to the second logic operator, which is OR. I could put this as an OR. What OR means is that not both of them have to be true, only one of them. As long as one of these two statements is true, the program will run, because the condition will be true or accomplished. So let's save this. Let's compile logic. Let's run it. And it's asking for two values. So on this one, we're using the OR, which means that I can put one as 3 and the other one as 8. And that should still be true because now it's only one of them. One of them is required to be true. This is what OR means, either or. If one is true, the program is good. The not works out a little bit different. What we could do here is put if A is not equal to 5, and let's combine them here so you can see, and B is not equal to 3. So now we're combining the arithmetic operator, which is the equal, and the not. The not is saying that as long as this is not equal, this is a not equal to 3, the program is good. So now we have two conditions with both of them with a not. So as long as A is not equal to 5 and B is not equal to 3, program should run. Let's try it out. So what I want to is not equal to 5 and not equal to 3. So as you can see, the program is good. But if we run it again and I put a 5, and this one we can leave it as a 7, so one of them is not true, because here the program is asking me for A not to be 5, but I'm inputting an A. So let's go ahead and do it. And as you can see, there's not, the program ends because this function is not true. Let's move on. Conditional statements. The if statement allows you to execute a section of code only if a condition is true. You can add more options using the else if. This is the structure of an if statement. You're going to put if, you're going to open parentheses, you're going to set a condition, you're going to open a bracket and a closing bracket, and whatever is inside those two brackets is the code that you want to be executed. I had prepared another program for this one. So here a equals 18. Wait, give me a second, I'll be right back. Sorry for the last pause. So I prepare a program that what it does is ask you if you're pretty much 18 or older or younger. So what I did here, I set a variable to 18. This is gonna be like my condition. This is gonna work out for me as my condition. And I initialize a variable called user. This I'm gonna use it to store whatever the user inputs. So what the program does is it's gonna display a question, how old are you? It's gonna receive an input for the user with the sin. It's gonna store it in the integer I initialized before. And then here's where we're looking for the if statement. This if statement, what it's gonna do is if the user input whatever is the age of the user, it's greater than or equal to my A, which is 18, which I set it over here on top, it's gonna see out you're eligible to vote. Why? Because you're over 18. Then there's another if, but this if you're gonna add an else before it. Why? Because the else what it does is that if this condition is not true, it's gonna jump to the next one. So if this condition is not true, let's say the user puts 16, it's gonna say okay, if user 16 is greater than or equal to 18, which is not, it's gonna ignore this line. What it's gonna do is gonna jump to the next one, and it's gonna check for another condition, the next condition. So my else if is my second condition. It's gonna be user is less than A. So my 16 in this case is gonna be less than 18. So it's gonna execute this part of the code. You can do this infinitely with more else if. You can add here an else if, and so on and so on and so on, and add more conditions and more conditions, so you can cover almost every possible situation. So let me run and compile this. So here you go, it's asking me how old are you. In my case I'm 18. It says here I'm eligible to vote. If I were to run it again and I put 15, as you can see, the program ignored this line and jump onto the next condition, and since this condition was true, it showed that I'm not eligible to vote. Another part of this is just an else. What it'll do, it's that you can establish another condition. Not a condition. You can establish another part of code, like cout not valid. In case this condition is not true and this condition is not true, what the program will do is else. Everything that does not satisfy this condition or this condition is gonna jump to this part. What this part is useful for is you could put a break. A break means that the program will stop running or not. Sorry, I get super confused with my loops. Um, Here you can establish another part of code. So if this condition is not accomplished and this one is not accomplished, you can jump onto something else. In this case, it's pretty much impossible unless you input something that's not a number, but you could do this for every other case that does not satisfy any condition that you established before. Loop statements. The first loop that we learned in class was the while loop. The while loop, it's a loop that uses one condition and executes as long as that condition is true. So I had prepared one of those two. So here you go. I established my variable, a boolean a. Boolean is the data type, and a is equal to true. And I say while a equals true, this is my condition. As long as a equals true, this is going to repeat and repeat and repeat and repeat and repeat again. And I put cout infinite. So as long as a equals true, my program will go on and go on and go on to display infinite. That's it. That's my program. So let's see what happens when I run it. env.cpp g++ env.cpp, and I can run it. And as you can see, since a is always true because there's nothing that changes a, infinite is literally printing infinite on my program. It's not stopping. As you can see, if I display the console, it's infinitely going and going and going and going. You can see right here that I can even go down because it's going and going and going. So let me erase this. Let's see what I have here. Oh, sorry. I thought I had another slide of that. Okay, so this can get fixed easily and not be an infinite loop. This is what it's called, an infinite loop, because it's never going to stop. So what we can do, it's add another line and set a equals false. Simple as that. So my program is gonna start. It's gonna say while a is true, and then while a equals true, it's gonna cout infinite. But since I added another line that says that a is now equals false, a equals false now, the program will stop because a is not true anymore. If this wasn't here, it's going on and on and on because there's nothing changing a. Let's try it. G++ env.cpp, run it. Oh, what? Let me do a little pause here. Sorry for the pauses. I'm having a little bit of trouble with my Visual Studio Code app. It's not compiling correctly. Let's go ahead and move on to the next one. The next loop we learn here is a for loop. The for loop consists of three main parts for it to be initialized, for it to work. The first one, you're gonna write for, you're gonna open a parenthesis, and what you're gonna do is you're gonna initialize a variable, which is gonna be, again, in the if, this is going to be your condition. Oh, sorry. It's going to be your condition. So you want to start a equals to 0. You're setting a variable, you're creating it and saying it's equal to 0. Then you're going to establish your test, which is, again, like another condition. As long as a is less than 5, is gonna be where it's gonna be testing what the limit, you can call it like that, the limit of the for loop is going to be. And then you're gonna put an update. Update means that you're changing the first variable that you created so that it can stop somewhere. So what the for loop does is, as long as a is less than 5, it's gonna execute whatever you put in the code. And then after reading up to here, it executes the code, but at the same time it also updates. That's what it called update. It also updates the variable. So what this is reading is, okay, my a is equal to 0. A0 is less than 5, so I'm gonna execute the code that is inside, and I'm gonna add 1 to my a. So now my a, it's 1, and then a, which is 1 now, is less than 5 still. So I'm gonna execute again the code. I'm gonna do plus plus, which is plus 1, and now a is 2. Let's try this in this program. Let me erase this program. Oh, for a integer a is equal to 0, you initialize it. As long as a is less than, let's put it 3, a plus plus. And what I wanted to do is yarn a star. This is the example Dr. Kim used. Inline. Yeah, inline. So what this program is going to read is that my a0 is less than 3, so it's gonna see out a star. It's gonna add 1 to my a, and it's gonna repeat, but now my a is 1. It's gonna go again. It's still less than 3. It's gonna execute the code, which is counting 1 star, and then it's going to add another point to my a, which is now 2, still less than 3. It's gonna execute it again. It's gonna add another 1, and now it's gonna be 3. And since this condition is not true anymore, it's gonna stop running the program. Let's try it on G++. Final.cpp. I don't know why it's not compiling it. Excuse me. G++. Final.cpp. I'm having a little trouble with my program. Let me restart it. G++ final.cpp. Now it compile. Here you go. As you can see, it executed the code 3 times, and when a was equal to 3, it stopped because this condition was not true anymore, because a was 3 and 3 is not less than 3, it's equal to 3. So if you put this up to, let's say, 20, you save it, you compile it, and you run it. As you can see, it did it 20 times and then it stopped. The next thing that you have here is a nested for loop. This is an example Dr. Kim used. I'm gonna recreate it again so I can explain it to you. And what you can do is you can put a for loop inside another for loop, and this allows this line to be executed 5 times, and then this code, all of it, be done another 5 times. 5 times because we set the limit to 5. So let's try it on with the code that we just did. But what we're gonna do is we're gonna remove the end line. That way it's not so big, that big. So here we just have to indent everything correctly, and we can add a 4. We have to use another variable, integer b equals 0. B is less than, less than 20. Let's put it the same as the one down here. B++. So what this program is gonna give me is gonna print 20 of these. 20 because I removed the end line, so now it's not gonna be one and then the other one. It's gonna be 20 of this, and that is going to repeat 20 times because this is repeating 20 times, and then the whole thing is inside this for loop, which is repeating another 20 times. So let's try it. We should have 20 lines with 20 stars. G++ final.cpp cpp, we execute it. Oh, I forgot the end line. So it gave me 20 stars 20 times in a row. Sorry. If we add an end line, it should be the way I explained it before. So as you can see, it's giving me 20 times 20 single stars. Next topic is arrays. Arrays are memories, are a set of memories with a set amount of spaces determined by you. They can store different types of data, but only a single type per array. So this is how you initialize an array. It's basically a group of slots where you can store data into each slot. You have to set a type. The type of data that this array is receiving is double, which means they can have a decimal, or they must have a decimal more than likely. The name, you can name it whatever it is, whatever you want. And then the size. This size is the limit that you can have 10 different variables or 10 different numbers in here. So I had prepared another example for this one. No, I didn't prepare an example. Let's do something. I set it up. Let's do a new one. Let's do just integer average. No, let's go on with the one I had. Sorry, double average 10. Let's say this is going to be something for the average of your classes. So we can see out insert your classes averages. Say into averages one 0. We're gonna copy this and we're gonna put it into 1. I'm just gonna do 3. So since this is going with binary, the first number is actually 0. So we're gonna ask for class averages. We can have a double because averages more than likely have a point. And then we're gonna do cout averages 2. So as you can see, I'm gonna ask for 3 numbers, and this is gonna display the very last one. Let's put it to try. Array.cpp. We execute it. Insert your class averages. 10.5, I don't know, 8.65 and 7.5. As you can see, this store into the same thing, which is averages. This is my array, and you just have to change which slot you're using. So I'm gonna have a little pause here. So what I was thinking, it was that we can combine this with a for loop, so you guys can see that it's storing it into a different slot and not just only one. So we can use a for loop for integer a equals 0. A is less than, we only did 3, so we can do 3. A plus plus. And what we're gonna ask the program to do is cout the averages, and instead of using a number, we're gonna put a, because my a is gonna start off at 0, which the first thing is gonna display is my average is 0, then it's gonna go to 1, and then it's gonna go to 3. So that way we can display all of them at the same time. Inline. That should do it. We can save it. We can compile it and run it. So I got a 9.65, an 8.5, and a 7.45. Oh, it didn't. Whoa, what happened here? Again, I'm having trouble, so I already fixed it. We got to compile it, we run it, and we say 8.65, 7.54, 9.6, and as you can see, it stored every single value into another slot of my array. Functions are part of codes that can be separated so they can be used throughout the main function just by calling them using its name. Here I'm gonna go back and refer to a homework that way you did a lab. My function, you have to set what type of data you're using in your function, your name of your function, and here in parentheses you have to put the input that is receiving. So what you want to do, in this case we're trying to translate dollars to pesos, so you're gonna set a variable which is gonna be whatever. This is gonna be your input, and this variable that you're initializing here is gonna be what's gonna come out of your function. So result equals a, which is your input, times 1928, which in this case is the transaction value. So in your main function, and you have to put return result. So this basically means that this is what is going out from your function. Out of this, you're receiving this input, and you're returning, you're throwing out this. So in your main function, instead of having to write all of these, which in this case is a short function, but it could be a lot more complicated than like the ones we did for our last homework, our group assignment. So here you're setting the variable double A, which is where you're gonna send to your function, and you're counting US dollars because you're asking the user how much dollars he has, and you're putting it into A, and then you're gonna see out Mexican pesos because you already did it. And instead of having to go ahead and here in between these two multiply the whatever input you got from the user to the exchange value and then storing it again and then counting again, you're just gonna call your function, which is exchange, and you're gonna tell them what is it gonna use for it. So you can try this one, G++ lab 49.cpp. We can execute it, and as you will be able to see it right here. It's asking me how many dollars I have. So let's say I have $2, and easy as that is gonna give me my 39.56. So what it did here is I seen the $2, and this did nothing because you already have a function that does it for you. And then you're gonna put the actual result, and then here is where you're going to do something. You're gonna tell him do the exchange, which is your function, do this function with A, whatever the input was. So work it out, and then here instead of having exchange A counting, you're gonna have the return of that. So it's the output of this. I know this is not the best video. I apologize for my accent. I'm really nervous. I had a really hard time with my computer, which is it's not an excuse. It's just I had a really bad time working on it. I'm very nervous, as you can tell by my voice is breaking. I had to do multiple pauses. I'm sorry for not doing as well as you expected, Dr. Kim. But I hope this does it for my final, at least. Thank you very much, and that's the end of the video.